All right, we're working through the Limits Review Worksheet here, and it says refer to the graph below in order to answer the following questions. If a limit does not exist, explain why. Uh, so we're looking at 1 through 15 here. Here's the graph below. Uh, limit as x approaches a specific x value. We're asking to find a limit. So limit is always referring to the y value. So the y value is given by what you see here marked off on the y-axis. So as we find the limits, it's always going to be in reference to one of these letters that we see on the vertical y-axis. All right, so number 1 here, limit as x approaches infinity of g of x. So as we approach infinity, that means we're following the right arrow of the graph off the graph, and we're seeing, does the graph level off at a specific y value? Does it shoot up to positive infinity? Does it go down to negative infinity? So as we follow the right arrow off the graph, we see that this graph is leveling off at right above this, right about this line, and that line is a y value of h. So therefore, the limit is equal to h. Okay, number 2, limit as x approaches negative infinity. So negative infinity, we want to follow the left arrow off the graph as we approach negative infinity, and we want to see, does the graph level off. Here we're following the left branch. The left branch of the graph, as it goes off the graph, we see that it's leveling off at a y value of I. So therefore, that's where the limit is. As we approach A from the right side of A, so as we approach A from the right side of A, here's A. We're going to choose the right branch because we're approaching A from the right side of A, and we see the graph is shooting up to positive infinity. Okay, number 4, as we approach limit as x approaches A from the left side of A. So here's A, here's the x value of A. As we approach A from the left side of A, we're following this left branch to up towards positive infinity. Okay. As we approach A, from either side of A, does the graph, we see the limit does not exist because the graph, they're not approaching the same real number. However, they're both approaching infinity, so we can say that the graph does not exist, but more specifically, it does not exist in the sense that they are both shooting up to positive infinity. Okay, number 6, x approaching 0. So in order for a limit to exist, the graph has to approach the same y value on either side of 0. So here's 0. On the other side of 0, we see the graph is connecting through the y value of k, so therefore the limit is equal to k. As we approach B from the right side of B, so as we approach B from the right side of B, here's B right here. As we approach B from the right side of B, we're choosing the right branch, and we see the right branch is shooting down to negative infinity. Okay. As we approach B from the left side of B, so here's B, we're approaching B from the left side of B, we're following this branch, and we see the graph is heading towards a y value of 0. Okay. Number 9. Limit as x approaches B. So limit as x approaches B, and in order for a limit to exist, the graph has to approach the same y value from either side, and we see there's a disconnect in the graph, so therefore the limit does not exist. And this is going to be also considered a non-removable discontinuity because the one-side limits do not agree. Number 10, limit as x approaches C. So as we approach C, we see from the left side it's approaching negative infinity, from the right side it's approaching a different y value, f. So therefore, again, another non-removable discontinuity. The one-side limits do not agree. Okay. Number 11, x approaches D. So as we approach D, we see that the graph is going through the y value. So the function is continuous. So if the function is continuous, the limit will exist where the order pair exists. So limit is equal to 0. As we approach E, we see that the graph is connected through E, through the y value E, and then it's just going to take the same value as the order pair. And at E, the y value is at L, so L is the limit. G of E, we're simply looking for the order pair, so at E, the y value is L. 14, we're looking for the order pair at 0. the y value is k. 15, g of b, we're looking for the y value again. So at b, the y value is at this point here. So at b, on b, the only point that we see that's defined is at the y value of m.